Good morning, good evening, good afternoon. It actually is evening for me right now. I'm going to do a video on completing the square, and this is part one. There's 3 parts to completing the square that we're going to talk about. We might get them all in one video, or I might make them into 2. The whole reason why we want to learn how to complete the square is if I'm given a quadratic function, and we have the 3 forms of quadratics. We have the standard form, we have vertex form, and then we have factored form. We made the 3 forms of quadratic functions before, and each one tells me different information. The standard form tells me that y-intercept, the vertex form tells me the vertex, and the factored form, the best reason for those, it tells me the zeros or those x-intercepts. And so these 3 forms are really important, and there's things that we can do to get from one form to the other. And so what we're doing to complete the square, the reason why, is so I can go from factored form to vertex form. And so we practice that. So if I give you one in standard form, I'm going to go from standard form to vertex form. So if I give you an equation in standard form, such as our first example is going to be f of x equals x squared plus 6x plus, and then I'm going to say some number. If I give you this in standard form, I want to know what the vertex is so I can graph this easily, because I know the vertex will be that middle point on my parabola. But I need to make sure that I can figure out what goes here to make a perfect square, because vertex form will look like f of x equals a parentheses x minus h squared plus k. So I want to get it to be here. This right here is a perfect square because it's something squared. So I need to get this part here to be a square so that I can get it into my vertex form. So we're going to look at this problem, and this is like part 1. This is the baby part. So I have this, and I'm trying to figure out what number goes here to make this a perfect square. So there's really 2 ways that we've been doing this a lot. I guess there's 3 ways, but I'm going to focus on 2 of them. So we can either draw the picture, and to do the picture we're basing it off of using algebra tiles, or we can do it with algebra. So there's parts that go together, and I'll be highlighting where those connections are for you. So when I do the picture, I'm trying to figure out what number can go here so that this makes a perfect square. And so I know that I have one of these. This is my x squared, and I have 6 of these. So I'm not going to actually do all of it, but I have 6 of these. And then I have who knows how many numbers of these. That's what I'm trying to figure out. Do I have 1? Or 2, or 20, or 30, I don't know. So I'm going to have trying to figure out how many of those I need right now. If I have 1 of these and 6 of those. So we're going to just stick with the pictures, because in class you've done a lot of algebra tiles already. So my picture looks like I have a square, okay, and I have a square, and then I have 6 of these x's. So what we were doing in class is we were saying, okay, well, if I have 6 x's, I know I have an x here. How many of those x's, or I have a x square here. We can draw that. That's my x square. How many x's do I have on either side of this to make a complete square? And so we were doing 6 divided by 3. 6 divided by 2. And that gives me 3 on either side. So I have 1 there. So that gives me 1, 2, 3 x's. And then I have, so there's my 3 x's. And then I have 1, 2, 3 there. So this length is x plus 3. And this length now is x plus 3. So I have a square. And then that means this is my x squared. 3 x's, and this is 9. So to make that perfect unit, this is what I'm wondering. What is this square? How many of those little pieces do I have? So I have 9 of them. So then this becomes, if I plug it in, I have x squared plus 6x plus 9. So that's my perfect square. And the whole point of this is to know what that was. So now I want to write this in vertex form. So that's my standard form. I've been writing SF for that. So in vertex form, I have f of x equals, so this is the inside, and vertex form is what's the outside. So it's x plus 3 is my side lengths squared. And then we need that plus k, and so I have a perfect square. There's nothing extra over on the outside, so I just put plus 0. And so now if I know that, I know my vertex is what makes this 0 inside there. So that's negative 3. And then if this is 0, that's negative 3, plus 3 is 0, then I have my k over here, which is just 0. So that's my vertex. So that's with my algebra tiles or my picture. Some of you really like to do the generic area model instead, which comes directly from our picture. And so you have x plus 3, x plus 3, so that gives you x squared, 3x, 3x, and 9. And so use some color. This 9 and that 9 are connected, and this 3 x's right here are the same as those 3 x's. And same thing here, those 3 x's are the same as those 3 x's. And then this x squared is the same as that x squared. So I still have the exact same representation. It's just instead of showing each individual x and each individual little box for the units, I'm just going to use the numbers instead. So a lot of you are starting to like to use this instead, especially when we start getting that b term, this middle term, which you can't divide by 2 evenly if it's not an even number. So if that's odd, then I typically am going to start going straight to my area model for that. So there's algebra tiles. In the algebra, a lot of you are thinking this. So f of x equals x squared plus 6x plus something. So remember, in standard form, it's f of x equals a x squared plus b x plus c. So in this example, this c is my b term, and I need to know what do I do to that c number to get that. So what we were doing is we literally here divided this middle term, that 6, in half to get 3 and 3 on either side of my x. So to get c, I first took the b term and I divided it in half, and then that gave me a square down here that was 3 by 3. So I multiplied it by itself, or I squared it, and that's how I got the number 9 there. So with the calculations, I would go c equals, b is 6 divided by 2, and then I square it. So 6 divided by 2 is 3, squared c equals 9. So then I just plug that 9 back in there, but that 9 is no different than the 9 here. So there's a connection there. That's the same 9s. And then that number 3, this number 3 here is the same 3 as I have up there, which is also the same 3 that I have over here. So there's those connections going on. And so last but not least, I'm going to plug it in. So f of x equals x squared plus 6x plus 9. And that matches right there. Same thing. Just a different way to get to it. And then in vertex form, we're again at the same thing. Now you have to be thinking factors though, because you're trying to think what adds to 6 and multiplies to 9. So hopefully you are, I would honestly go from here to factor straight down here again. And so what times what gives you 3, or gives you 9, is that 3. So we have x plus 3 squared, and then there's nothing else left over. So I would just be doing that. Okay, so that's what I want to do if I want to just know what number do I add. And then sometimes we're given perfect squares, and so we are just going to say, okay, is that a perfect square or not? If it is, we'll do this thing to prove, okay, and that's what my square is. My vertex form is, and notice that's the same thing as I have right there. So the vertex is still going to be the same. -3, 0. Again, what makes this be 0 is -3. When that's 0, then that's just 0. So that's my y value. All right. So that was part 1. And I'm going to do part 2 on the same page. Or actually on the next page, but the same video. So this is completing the square. Square part 2. And again, I'm making this video on 11/1/18. So this is when do I have too many units? What do I do with that? So in this problem, we're going to look at the equation f of x equals x squared plus 8x plus 20. So in this example, sorry for that fuzziness. For this example, I am given standard form, and I need to know what is vertex form. So we're going to do this 2 ways with the picture, and then, yeah, we'll do this with the picture, and then we'll do it in the algebra method also. So I am going to separate this into 2 parts. So I have x squared plus 8x plus 20. So I'm going to, again, make my square. And I'm already thinking I need half of that. So half of 8, so I'm already doing 8 divided by 2 in my head, gives me 4. So I know that I'm going to have a square. And it's going to have 4 x's on either side. 1, 2, 3, 4. 1, 2, 3, 4. So this is x plus 4 and x plus 4. And when I do that, this square down here, this is only 16 units. But I was given 20. I can't just not include them. They have to be somewhere in this, so I still need them. So we still need 4 units in our problem. So we make our square, and then we just, next to our picture, add our 4 units. That's it. So then I do the same thing that I did before to go to vertex form. And my side lengths are x plus 4 and x plus 4. So I square that. That gives me this x plus, that gives me the 16 units. And I have 4 left on the outside. So I just go plus 4. And so from there, my vertex is, what makes this become 0 is a -4. And then if that becomes 0, my y value gives me positive 4. So that's my vertex. In algebra, what you can do is, I'm going to put f of x there. In the algebra side, I'm going to actually do that on my next video because this is almost 15 minutes. So the picture method works every time. You can do the area model if you would rather do that. Might be a little bit easier, especially again if you have an odd b value. So again, you would just have your x plus 4, x plus 4. That 4 came from knowing that you did the 8 divided by 2 to get 4. So you have x squared, 4x, 4x, and this is 16, but you need 20, so you go 16 plus 4 gives you the 20, so you have this extra 4. So you can just really next to it put plus 4, and then go straight back from there to your equation. So this would be a little bit easier maybe than having to draw the picture out. All right, so that's video 1. I'm going to start video 2. Goodbye.